Hi, and welcome to today's lesson. Today we're going over algebraic word problems. So, the ability to translate words and phrases into mathematical expressions and equations is a fundamental skill in algebra, especially in standardized tests like the ACT and SAT. So, today we're just going to go over some problems where we have to directly translate phrases into specific algebraic expressions. So we'll begin with the addition phrases. So anytime you see the sum of, you know we're talking about addition. So if I said something like the sum of, if I said something like the sum of a number and 3, well, that would be just x plus 3, right? Anytime a phrase refers to a number, so a number in an algebraic word problem, and it doesn't tell you what that number is, that's going to be x, or your unknown variable. Okay. So again, if you encounter the phrase the sum of, whether it's two numbers, so if they say something like the sum of 3 and 9, well, it's just 3 plus 9, which is 12. But if they say something like the sum of a number and some other number like 3, you would be directly translating your phrase into this expression. Okay. Another phrase that has to do with addition is more than. So if I say something like 3 more than 5, that would be another way of saying 3 plus 5. All right. So another example is 5 more than a number. So again, a number is referring to your unknown. So you would have to use something like x plus 5. Okay. So that would be 5 more than a number. And lastly, if you run into plus, you know you're dealing with addition. So if I said 3 plus 3, well, that would be 3 plus 3. Next, we go over the subtraction phrases. So you might encounter the phrase less than and less when you're having to solve problems, word problems having to do with subtraction. Now, there is a difference between less than and less. So if I said something like 5 less than 10, okay, 5 less than 10. You have to realize that what this is saying is it's telling me to take 5 from 10. Okay, in other words, the 10 comes before the 5 when you're subtracting. This is different from the word less. So if I said 3 less than 5, well, sorry, not less than, 3 less 5, well, that would be the same thing as 3 minus 5, right? It's just a direct translation into subtraction. If I said something like x, so x less 3, so that would be x minus 3. However, if I said 5 less than x, okay, so if I said something like 5 less than x, well, the x comes first. Okay? You're taking away 5 from x. Okay? The next phrase or word would be minus. Okay? And again, this is a direct translation of minus into subtraction. So 5 minus 1, well, that would be 5 minus 1, right? It's direct. Same thing as saying plus. Subtracted from, this is similar to less than. So if I say something like 10 subtracted from 20, okay, 10 subtracted from 20 means the 20 comes first. You're subtracting 10 from 20. Okay? The next thing you need to know is the multiplication phrases. So if you run into the word times, okay, so if I said something like 3 times 5, this is a direct translation of multiplication if you hear the word times. So this is similar to saying plus. It's similar to saying minus. So if I said 3 times 5, okay, 3 times 5, that is the same thing as 3 times 5, okay? Next thing you need to know is multiplied by. And again, this is pretty self-evident. So if you hear or read multiplied by, so 3 multiplied by 5 would be written just like that. X multiplied by 7, you could write it as x times 7 like that, or 7x. Okay. And another way of saying multiplication is product of. So you might hear something like the product of 5 and 5. Well, product means multiplication, so you would write 5 times 5. Or if you hear something like the product of 5 and the sum of a number and 3. So the product of 5 and the sum of a number and 3 would be something like x, a number, and I just mentioned sum, so you would be adding 3 to that, and that's how you could write the product of 5 and the sum of x and 3, okay? And the next thing you need to know is the division phrases. So if you hear or read the quotient, you know you're dealing with division. So if I said the quotient of 6 and 3, that would be 6 over 3, which is 2, okay? Another phrase you might hear is divided by, and that's pretty self-evident, okay? So 6 divided by 3 would be written as 6 over 3. Another way you might hear of division is the phrase the ratio of. So if you hear something like the ratio of 6 and 3, that would also be written as a division problem, 6 over 3. Okay, now let's go over some examples. Here it says, translate the words into an equation and solve for the unknown number. So let's go ahead and read. It says, the quotient of a number and 3 is added to 4 times a number. The result is the same as twice 3 less than the number. Find the number. Okay, well, we just learned that quotient of refers to division, and a number refers to our unknown, or x. Okay, so if it says the quotient of a number and 3, then we have x over 3. So that would be a quotient of a number 3, a number and 3. And it's added to 4 times the number. Now, when you read the number, what's happening is it's referring to this number. In other words, the same x. So the quotient of a number and 3, x divided by 3, is added to 4 times the number, means we are adding 4 times the number, or 4x. Okay? It's referring to the same unknown. And the result is the same as. This is equivalent to saying equals, right? Because that's what equals means. It means your left side is equivalent or the same as your right side. So when you read or hear the result is the same as, that's saying to put an equal sign. So here it says twice 3 less than the number. So twice means to multiply by 2, right? Twice 3 less than the number means the quantity of 3 less than. So 3 comes after the number. And of course, the number, again, referring to your unknown, which is x. Okay, so on the right side, we have twice 3 less than the number. 2 times 3 less than x. And it tells us to find a number. So let's go ahead and solve for x. The first thing you want to do is get rid of this fraction. So we're just going to multiply the whole thing by 3. Okay. I'm going to simplify this one first. So I'm going to distribute the 2. So that's going to give us 2x minus 6. And then I'm going to multiply this thing by 3. Okay. And of course, the purpose is to get rid of this 3 in this fraction. Okay, so when we do that, we end up with x, right? The 3's cancel, plus 12x equals. So here I'm multiplying by 3, not raising by the power of 3. So that's going to give us 6x minus 18. 6 times 3 is 18. And we can combine like terms. So on the left side, we have 13x. On the right side, we have 6x. On the right side, we have 6x minus 18. So we can subtract 6x from both sides. And we're left with, let's see, 7x on the left side and negative 18 on the right side. To isolate x, we divide both sides by 7. 7's cancel out on the left side. So our unknown value, our final answer, is going to be x equals negative 18 over 7. All right, let's go over another example. Again, we're just translating words into an equation and solving for the unknown. Here it says 10 is the same as. So right there is pretty self-evident. 10, okay, is the same as means equals, is the same as. The difference of twice a number and the quantity of negative 6 times number minus 2. So it's going to be, so on the right side, we're going to have a difference, meaning something is being subtracted from something else, okay? So the difference of twice a number, so a number is our x, or what we're solving for. So it's going to be 2x. And the quantity, again, it says the difference, so we're subtracting. The difference of twice a number and the quantity of negative 6 times the number. So quantity is basically going to mean to put it in parentheses, okay? The quantity of some expression. The quantity of negative 6 times the number means to multiply negative 6 and the number, which is x, minus 2. Okay, let's read that again. 10 is the same as, so 10 equals the difference, okay? Meaning the right side is the whole of the right side is going to be a subtraction expression. So 10 is the same as the difference of twice a number. So here, twice a number, twice x, okay? And the quantity, so here's our quantity in parentheses, of negative 6 times the number, which is written as negative 6x minus 2, okay? So let's go ahead and solve now that we've written our expression or equation. So the only thing you really need to do beforehand is to simplify the right side. So I'm just going to distribute in this negative, and you're going to end up with positive 6x and then positive 2. You can combine like terms on your right side. That'll give you 8x plus 2. So we have 10 equals 8x plus 2. And we can solve for x by first subtracting 2 from both sides. We have 8 on the left side and 8x on the right side. Okay? To fully isolate x, we divide both sides by 8. And that gives us 8 over 8, which is 1. So x equals 1. Okay? Let's try another one. Again, we're translating these words into an equation and solving for an x. That's all we're doing. And actually, if you look at these problems, they're not too hard because it's not actually giving us the regular problems that we might be used to. In other words, it's not giving us some kind of situation having to do with, for example, finding out things like areas or perimeters. It's just giving us straight the phrases that can be directly translated into algebraic expressions. So here we have, it says the sum of 12 times a number and 7 is the same as 10 multiplied by the number decreased by 9. So the sum of 12 times a number, okay, so 12 times a number is going to be our x, okay, and 7. So the sum of 12 times a number and 7 is the same as, okay, that's going to be our equal sign. 10 multiplied by the number, so 10x, decreased by 9. Easy. Subtract 9. Okay, and now we can just solve for x. So subtract 10x from both sides, and we're going to subtract 7 from both sides. So when we do that, we get 2x equals negative 9 and negative 7 is going to be negative 16. Divide both sides by 2, and that will give us x equals negative 8. And that's our answer. Let's try one last example. Exactly the same thing. Translate the words into an equation and solve for the unknown number. Okay? So this one, it's telling us the quotient of. So that's going to be a division problem. So the quotient of 5 and 3. So the quotient of 5 and 3 is going to be 5 over 3 multiplied by a number. That's our x, okay, or our unknown. So the quotient of 5 and 3 is multiplied by a number and added to 1. Okay. Now, addition is commutative, so you could have written this as 1 plus 5 over 3 times x, or you could just write it like this. It doesn't matter. Addition is commutative, so order doesn't matter. So the quotient of 5 and 3 is multiplied by a number and added to 1. The result is the same as, it says the result is the same as, so that's telling us to put the equal sign. So the result of whatever this on the left side is going to be equal to the right side. And on the right side, we have the quotient, again, it's going to be division, the quotient of negative 5 and 2. The quotient of negative 5 and 2, okay? Negative 5 over 2 times the number, well, x, less 22 divided by 3. Less 22 divided by 3. That means to subtract 22 over 3. Find a number, okay? Once again, it's telling us the quotient of 5 and 3. That's 5 over 3 multiplied by a number times x added to 1. Add 1 equals the quotient of negative 5 and 2. That's going to be negative, the fraction negative 5 over 2 times the number x. Subtract less 22 divided by 3. Subtract 22 over 3. Okay? So to solve this equation, the first thing you want to do is multiply both sides by the LCD of 3 and 2. Okay? We don't like having fractions or dealing with fractions when we're solving for the unknown in a linear equation. So the LCD of 2 and 3, well, that's 6, right? The least common multiple of 2 and 3 is going to be 6. So that means I'm going to multiply everything, both sides, by 6. So when we do that, what's going to happen is the 3 goes into 6 twice. So 2 times 5 is 10. That's going to give us 10x plus 6 times 1 is 6 equals 2, right? This 2 goes into 6 3 times. 3 times this negative 5 is going to be negative 15x. And then 3, this 3 right here, goes into 6 twice. And 2 times a negative 22, right? This negative 22 is going to be negative 44, right? So just to verify, 6 times 22 over 3. 3 goes into 6 2 times. 2 times 22 equals 44. Okay. So now we've cleared the fractions. We can isolate our x variable. So let's add 15x to both sides and subtract 6 from both sides. When we do that, we can cross these out, and we're left with 10x plus 15x, which is 25x, equals negative 44 and negative 6 combined to negative 50. And we can divide both sides by 25. And that will give us a value. So x is going to equal, well, negative 50 divided by 25 is negative 2. Okay. And that is our answer.